Okay, so your potential divider, remember, is just two resistors. Sorry, it's just a fixed resistor and then two resistors in series. That can be fixed, that can be variable. And you need to remember the formula. V out here, right? You take it across R2, so this should be R2. And then since this V in is across R1 and R2, then there's R1 plus R2. Okay, so in this case, this is a potential divider or a potentiometer with variable. Right? There's your variable PD there. Right? So in the simplest form, two resistors connected to a cell, that's your cell, or it can be a rheostat to the cell with a sliding contact and another terminal providing the PD required. Okay, that's what we have shown you previously. Okay, let's derive the equation. Right, I just change it to R1. This is R2. This is V1. That's your V2. Right, this is an ideal voltmeter. That one you
go
can
back again, sorry.
okay.
Oh, that means they're trying to tell potential divider means they connect two resistor connect to this and that lah.
That's all.
Right.
Yeah, two resistors in series connected to a cell or source of
Cell
EMF.
or
And
a
then you
rheostat.
tap the output from one of the resistors, can be from the top, again from the bottom.
Check the sliding contact is the V out, right?
The what?
The
Don't worry about the
contact.
sliding contact. Sliding contact, I need to work with the potential divider, work with the rheostat. So don't worry about the sliding contact.
Okay.
Just know how to use the formula, derivation. That's your cell. That's your R1, R2. So across R1 is a potential difference. I just use a voltmeter to measure the potential difference across R1. And then across R2 is just your V2. So you must know from Kirchhoff's law, right? V equals to V1 plus V2. Right? That's your Kirchhoff's second law. V is V1 plus V2. Right? So we are going to derive this equation. You must know that your R1, your V1, this is your V1, over the total, that's your V, is just your R1 over R1 plus R2. That's easy to remember. V1, that's your V1, right? Over V1 plus V2, V1 plus V2 is your V. Then this becomes your R1, R1, R1 plus R2. That's your total resistance. Okay, let's look at this circuit there. Forget about this voltmeter. Right? The current flowing through the circuit, that's your current. How to calculate? That's your current. Right? It's just your V, your EMF, divided by R1 plus R2. Then we want to calculate your V1. Right? V1 is just your I times R1. V1 is potential difference across R1 equals to that current I times your R1. Okay, then we replace that I. Take it down here. R1 times that. So that's why we get this equation. Okay.
Yeah, V1 over V, correct, and then R1. Oh yeah, V1 is the output one, right?
Yeah, V1 is what we tap it from. Wherever one can be V2. But we want
and then
V1.
R1 over R1 plus R2, and then times with the V lah, the battery one. Yeah, okay. And then wait, V equals to potential difference. So across R1 means it's IR. Wait, what? Which I'm confused. R1 equals to IR1. Okay. That means they cross multiply. Sure.
Okay,
No. The V equals to PD across R1 equals to IR1. I don't get it.
this is your V1. V1 is across
Okay.
here. So you times
Yes.
the current times R1. Not current times R1, that's all. This current is passing through R2 and R1.
V equals to IR lah.
So it's just I times R1. That's what we are doing here. Then replacing this I with this value. Get the answer. Yeah,
So that's it lah. Sure.
that's all. If you want the derivation, but no need to derive, memorize it, unless they ask you to derive. Yeah, can or not? Can or not?
No, wait no. Okay. Now I understand. R1 over R1 plus R2 times V lah, basically, right? Sure.
Just remember, R1, that's your R1, that's your V1. And this V is the total potential across this. Right? So you just, the bottom one is the same thing, the total resistance, that's all, R1 plus R2. That's how to remember. Okay. Okay, remember the equation, or it can be this equation. It's just a ratio, that's all. It's R1 over R2 is V1 over V2, that's all. Right? And then this is usually where we use electronic, where you study electronic or transistor, we prefer to write this way rather than draw it this way. Right? Yeah, draw a separate battery there. Just put a voltage there. Okay with that? Yep. What is the problem? Just memorize the equation. You'll do some question in a while. Okay or not? Yep. What's the problem?
No. Wait down.
Just go back and memorize. Nothing you can do now. The way to memorize is just to do the calculation, do the solving the problem, which we'll do in a while. Very easy to memorize. R1
Yeah,
over
but why the
R2.
V1 over V2 equals to R1 over R2?
Go and
The
show
up one
yourself.
is different, down
Go
one
and show
different.
yourself. Right? It's the same as I've
What?
already shown you already. Go and calculate yourself. I've shown you already. This one. It's just a ratio only. Yeah, it's just a ratio only. V1 over the whole thing is R1 over the whole resistance. That's what it's all about.
Yeah.
So when you come to here, it's the same thing. You can go and show yourself. Right? V1 over V2 is R1 over R2. Or just memorize it. This one you can show yourself. No need for me to show you everything. Just go and calculate your V2 from I times R2. Your V1 is I times
Yeah. V equals to IR and then
the current
V
is the
over
same.
R. Then you can start doing lah.
It's a simple calculation only.
That's why I'm thinking why the up one like quite special one.
It's just a ratio. That's why I told you, ratio. Just remember it's a ratio. The current is constant through R1 and R2. That's the reason why we get this equation. Right? So usually it's used with a special resistor. I think you probably study your light dependent resistor in your SPM. Right? Bright light, low resistance, darkness, high resistance, used as a light sensor. So in darkness, resistance is 10 mega ohm, and then bright light, a few hundred ohm. Okay, let's try see whether you know how to apply a ratio. What's the PD across the 40 ohm? That's your 10 volt. 40 ohm, 160 ohm, 2 kilo ohm, 8 kilo ohm. That's your voltmeter. So what is your PD across your 40 ohm? This one. You can work mentally. Doesn't take a long time. Yep.
Across 40 ohm. Okay.
Just using the previous equation that I've given you. That equation.
Yeah, this
This
equation,
equation, that
but just
equation.
not
That's
sure
all.
how to relate it to the question. Okay, go to the question, sir.
So it's 40 over
Yeah,
200
40 over
times 10.
160.
That's all.
Wait,
Right?
40 over 2. Oh,
over
yeah,
200 times
40 over,
10.
yeah, 40 over 200. Sure, they never show the battery. That's why I was confused.
The battery is up on top there. There's a 10 volt there. There's a 0 volt there. So battery is 10
Oh,
volt.
you didn't show the
Doesn't have to
battery.
show you. I already told you you're not paying attention in class. I just show you, explain to you. In electronic, we use it this way. Instead of battery, we put a volt there. And then there's a 0 there. Same as here.
Mm.
So there's a potential divider. This is also a potential divider. So you should be able to get a 2 volt there. How about across 160 volt?
Yeah, it's 160 divide 200 times 10. So 4 over 5 times 10 means you get 8.
No need so troublesome lah. Just take your 10 minus your 2 here. Yeah,
Yeah, is it correct?
faster.
Okay.
This is 10,
10 minus what?
10 minus 2
Yeah.
here. You get your 8 here.
Oh, yeah.
Yeah, about across 2 ohm. 2 kilo ohm, this one.
The answer is 2 kilovolt.
Answer how many volt? Across a 2 kilo
2
ohm.
kilovolt. 2 kilovolt.
2 kilovolt. How to get the 2 kilovolt? The highest you can get is 10 volt only.
Huh? No. 2 kilovolt over 2 plus 8. They are kilovolt, then times 10 lah.
So what's the answer?
The answer is 2.
Why take so long? Right, across 8 kilo ohm.
8. 8 also. 8
Yeah, 8 also.
10
So it's
minus
10
2.
minus 2. So what's the voltmeter reading?
Voltmeter reading.
Yeah.
Plus everything, right? It's 20.
No, just subtract. Take the potential difference across this one and the potential difference across here. Use that as a reference. Right? Potential across the 2 kilo ohm minus the potential difference across the 40. So it's 2 and 2. So it's 0. 2 minus 2 is 0. Not potential difference. Okay?
Wait, why is it 0 again, Che? Sorry, Che, I mean maybe.
Across your 40 ohm is 2 volt. Across a 2 kilo ohm is also 2 volt. So the potential difference XY is 0. 2 minus 2 is 0.
2 minus 2 is 0.
Yeah. Yeah, across X is 2, at X is 2, at Y is 2. So 2 minus 2 is 0. No reading. This is your Wisdom bridge.
Yeah, I don't understand, Che.
What is there to understand? 2 minus 2 is 0. What is there to understand?
No. I mean like.
You have already calculated already. Across your 4 ohm, 40 ohm is 2 volt. Across your 2 kilo ohm is also 2 volt. So 2 minus 2 is the potential difference across XY. So that's your voltmeter reading.
Wait, not the up one.
No need to worry about up one. If you want to use up one,
Oh, 8
up one
minus 8 also lah.
8 minus 8 is also 0.
Oh, I thought they plus.
You must use the two same reference, either the 0 volt or the 10 volt as a reference. You want to take the 2 up one, you take the 2 up one. Then calculate your XY. Yeah?
Okay.
Right? So it means that the potential at X and potential at Y is the same. Right? Or the potential difference is 0. So you put a galvanometer there, it will give you 0 current. That's why you will study in your Wisdom bridge, right? Later on. Okay, so these are the uses. As I say, thermistor stand for thermal resistor. Your syllabus doesn't mention about all these things. But I was surprised I do through one of the past year question. Right? You're supposed to know thermistor, but your syllabus is very vague. Doesn't matter. Yeah, you just remember thermal resistant. Right? Stand for thermal resistant. Thermistor. Just a short form of thermal resistor. That means
So
it
heat
responds.
resistor lah.
It's just a special resistor that responds to heat. Right? Or we call it heat sensor. Usually we are interested in what we call NTC, negative temperature coefficient. That means as it's actually a semiconductor. So as the temperature increases, the resistance decreases. Right? Make of semiconductor material. That's why it behaves this way. Right? NTC. The other one is BTC. I don't think we should bother about that. Right? Can be of different form. That's how it looks like. Okay. Yep. What's the problem? Nothing much to study. This one is just memory work.
No. Okay.
Okay. What's the answer for this one?
Boy.
Maximum is 5. So this 9 volt is shared between 5 and 5. So it's 4.5 here. Minimum, this is 0. So it will be 0. B. Okay.
Say the minimum one I don't understand, sir.
Minimum is 0. 0 ohm.
Where you get the 0?
This variable resistor can go from 0 to 5 kilo ohm. That's what I mean.
Oh.
Yeah?
Wait, then the up one?
Up one is fixed. 5 kilo ohm. Cannot change.
Oh, the one with the thermal
Variable means
one.
it can go from 0 to 5 kilo ohm.
Oh, okay.
Okay, we have to finish in 10 minutes time. Then that's for the hope for this for today. How about this one?
Okay. Then
Yep, what's the answer? Okay, such suggestion can come out because it doesn't even like dependent resistor. It may not be in your syllabus, but they have explained to you how does it do. So they just require to use your potential divider formula, that's all. So calculate for 10 ohm. Then what happened when it's 100 ohm?
So
Remember,
500 plus 100.
you are interested across the value that changes across the 500 ohm, not across the LDR. Always remember.
Oh, we don't care about the LDR lah.
Well, you don't care about LDR, care about LDR, but it's not across LDR. It's across the 500 ohm. That's your X there. Know how to read. That's your 30 volt. X is across the 500 ohm, not across the LDR. LDR is just to change the value of X as well.
Okay.
So calculate your potential difference across the 500 ohm when it is dark. Then when it is light.
Like I said, I mean the formula I know, but like I don't know which one to sub inside.
What do you need to start inside? I already told you already, it's across the 500. So it's across there. You're interested, the change in X is across 500.
So
R1.
500 over 500
there.
plus.
So darkness, 500 or 500 plus 1000 times your 30. It's your 30, 10 volt.
You don't take 100 plus 50, is it?
Where got 100? Don't
That
get
drops to
confused.
100.
This is 1000 in darkness.
Yes.
So don't bother about the 100 yet. Bright
Oh
light
yeah,
is
that
100.
one.
Bright light is 100.
Okay.
Focus on
Oh,
one by
so
one. First, focus the circuit on darkness. This is for darkness. Then focus it after that. Bright light. Bright light, this
answer
is
is
100.
donkey.
This 100.
Answer is donkey. Answer is donkey.
Yeah, answer is donkey.
Oh, so that means must do both lah.
Yeah, you
not
must
like
do
one
2
shot
times.
everything. Oh, now I understand. Okay.
This one. Then we call it a day. You can try the rest.
Okay.
Make sure you come and do your homework. Don't come without you doing your homework. You're wasting your parents' money. This is just reasoning only, not much calculation, very little calculation.
Okay. And then answer is A.
Yep. Let's go over roughly. Right? PD across R1 is 5 minus 3. Right? 5 minus 3 is 2 volt. So this one tell you that the PD across R1 equals to PD across R2. Right? R1, sorry.
Huh?
R1, R3, sorry, not R2.
Yeah, R1 equals to R3.
What am I doing? So R1 equals to R3. You are doing well. Then your resistance is proportional to voltage there. Right? So you know that this is 1 volt, this is 2 volt, this is 2 volt. Then it means that the current is the same. So it means that the resistance of R3 and R1 is the same and it's double that. That's what you get there. Right? Good. A. So we call it a day. Make sure you tell me, confirm with me. No more changes already.
Uh,
Okay?
okay.
Anything?
Okay.
You got a lot of questions to try out.
Sure, but like suddenly if I got class or anything on that day means then I'll inform, right? Sure. Then can write. Hello?
I think it's better not to change anymore next time. If you're going to have a class, don't like you to keep on changing the time.
No, but so far I don't have class at 4 to 5 because like all will settle in the morning and 12 o'clock already. That's why I always put 4 to 5 easier.
Okay. Next time we have it Saturday, we won't change anymore. Okay, we finish for
Yeah,
today.
actually, I prefer 1 hour lah.
It's really up to you. You keep on changing, I also don't like that.
No, it's because like 1 hour, I can focus better.
Okay, we finish for today.
Okay. Thank you, Che. Hello?
Yep. Have a good
Yeah,
day.
thank you, Che.
Bye.
You saw the test at 12, huh?
I already sent you already. You should focus yourself already. Don't every time want to
No,
repeat.
I already screenshot already.
I already given you already. So you take a photograph of it.
Took already. Okay, thank you, Che. Have a good day.
Maybe you can have it on Friday afternoon, no? If you prefer. Rather than on Saturday morning on the 11th, I think.
The test,
Ah,
okay, Ken. Yeah,
anyway,
school holiday, what, 2 weeks.
you think about it, and then let it confirm with me. Okay, we'll
Okay,
end it
thank you,
here.
Che. Okay, thank you,
Bye-bye.
Che. Bye-bye. Bye.